Hey everybody, welcome to our lesson for today. So yesterday we were solving one-step inequalities using addition and subtraction. Today our I can statement is we can solve one-step inequalities using multiplication and division. So let's go ahead and start with our warm-up real quick. It says graph each inequality. Don't worry about what he's saying there. I'm not sure what he's looking for there. So we have x is greater than 5.5. First thing I'm going to do is I'm going to put 0 on the graph, on the number line, and then I'm going to write a 5.5. It's a positive number, so it's got to be somewhere over here to the right of the 0. So actually what I'm going to do, sorry, I didn't notice at first that it was a decimal because I'm talking and writing at the same time. I'm going to put a 4 on here and I'm going to put a 5 on here, okay? This isn't quite to scale, so forgive me on that. But I know that 5.5 lives somewhere between, wow, you guys, I don't have my brain on today. Let me try this again. 5.5 lives somewhere between 5 and 6, not between 4 and 5. So I'm going to put another line right here to indicate 6. And then I'm going to put my dot in between them. Now before I write my dot, I'm going to say, should I use an open dot or a closed dot? And I have to look at this sign to know. Now if you have one of these guys, it's going to be an open dot. So I'm going to do an open dot right here, about halfway between the 5 and the 6. If it had been one of these guys, then I would use a closed dot, but it's not. So I'm going to do the open dot. Okay, so I have my open dot on 5.5 and I'm even going to label it. There we go. Tiny, but it's there. And now, what do I know about my inequality? It says x is greater than 5.5. So, in other words, all of the answers, and there are many, many answers to this, the whole range of answers are the numbers that are bigger than 5.5. So where do the bigger numbers live? They live over here to the right. This is the direction where numbers get bigger. Numbers get bigger to the right on a number line. They get smaller to the left. So as long as you can keep that straight, just remember that you're going towards those bigger numbers if your x is greater than. Okay, let's do the next one. It says y is less than or equal to negative 13 over 4. You know what I'm going to do? I'm going to turn that negative 13 over 4 into a decimal. So 13 divided by 4, and I'm going to get y is less than or equal to negative 3.25. For me, it's easier to picture that on the number line. If you'd rather turn it into a fraction, you certainly could. Let's see, 4 times 3, so 3 and 1/4. Don't forget the negative. So you could turn it into this if you'd rather. For me, I kind of like the decimals. You get to choose. Let's put the 0 on there. This is a negative number, so I need to put it over this way. And now negative 3.25, that's going to live somewhere between negative 3 and negative 4, somewhere in that range. And it's going to be not quite halfway. I'm going to put it right here. Before I draw my dot, though, I'm going to look at my sign. Now, this kind of sign that has the line underneath it where it says or equal to, that's going to mean you have a closed dot. So go ahead and fill that dot in all the way. And that just indicates that that number, the negative 3.25, is part of your solution. It's included in your solution set. Okay, so we have our closed dot. Let me label it. I'll label it right there. And now we know that y is less than negative 3.25. So all of the answers, you can always take this variable and just replace it with the word the answers. The answers are less than negative 3.25. So that means all the answers are smaller than negative 3.25. And where do smaller numbers live? They live to the left. So let's draw our line to the left. Make sure you do an arrow. Okay. And that's what you got to do. All right, so that was our warm-up. Made it a little trickier with those decimals, but I bet you guys got it. We're going to go ahead to the lesson now. It says, we've already established that adding and subtracting when solving an inequality does not change the direction of the inequality. Okay, don't worry about saying why it's true. It's just because you're moving the whole range of answers to the right if you're adding or to the left if you're subtracting. Let's go on to example 1. Now, example 1 is a little bit of an exploration, and if you like to explore this kind of stuff by yourself, I totally encourage you to pause the video right now and go through steps 1, 2, and 3, all the way, keep going until you get to here by yourself if you want to, and then just kind of fast forward through all my writing. And if you'd rather just wait and do it with me, that's perfectly fine too. If you're going to pause it now. Okay, and if you want to just do it with me, that's great. So I'm going to, number 1, put the correct inequality sign between the numbers. Number 2, perform the operations indicated, like right here. And then number 3, put the correct inequality between the new numbers. Okay, so -2 and 2. Well, -2 is smaller than 2. Now we're going to multiply both sides by 7. So times 7 times 7. -2 times 7 is -14. 2 times 7 is 14. Okay, now what sign is going to go in between? It is still going to be a less than sign. Great, let's do the next one. 18, 12. Which one's bigger? Let's let that alligator eat the 18 because 18 is greater than 12. So now we're going to divide by 6. Divide by 6 on both sides. You're going to get 3 and then you're going to get 2. Now which one of these is bigger? The 3 is bigger. So it looks like in both of these, did the signs change? Nope. Okay, let's keep going. This time we have 7 and we have -3. Which one's bigger? The 7 is bigger, so we're going to do a greater than sign. Now we have to multiply by -4, so times -4 on both sides. So 7 times -4 is -28. And -3 times -4, remember a negative times a negative equals a positive, so that's going to be +12. And now let's just compare -28 and 12, which one is bigger? Actually, in this case, the 12 is bigger, and so we have to draw our sign like this. Now I switched colors to draw attention to it. Why is this a big deal? Because they don't match. Okay, let's keep going. Okay, we have -20 and +35. Which one's bigger? That positive number is bigger. We'll do a less than sign. Now let's divide everything by -5. So -20 divided by -5. So a negative divided by negative is a positive, so it's going to be +4 here. And over here, positive divided by a negative is going to give us a negative, so we're going to have a -7. All right, which one of these two numbers is bigger? Well, the positive number is going to be bigger, right? 4 is bigger than -7. If we were on a number line, the 4 would be further to the right, and the 7 would be further to the left because they're positive and negative. So why did I write it in purple? Because once again, that sign seems to have changed direction. Very interesting. Okay, what do you notice about the inequalities? Okay, the inequalities, I'm just going to say sometimes they change direction. Or you could say they flip if you want. Sometimes they change direction. Okay, which operations change the direction of the inequality? This word, it's not quite the right word to use there. What is going to change the direction of the inequality? What's causing them to change? Like, is it multiplication? Let's see. In this one, does it change? No. We're using multiplication and it does not change. But in this one, we're using multiplication and it does change. What about over here? Division, is it changing the direction? No. What about over here? Division again, but it is changing the direction. So what's the difference? Here, the difference here is this one is multiplying by a positive and that one's multiplying by a negative. Seems like that negative number is making it switch. Let's check out the division though. Here we're dividing by a positive and here we're dividing by a negative. And in the negative case, it had to flip again. So it would seem that multiplying or dividing by a negative causes the inequality sign to flip or to change direction. Okay, so I'm going to say multiply or divide by a negative number. It's those negative numbers that are doing it. By a negative number makes the inequality sign change direction. I don't have room to write. I'm just going to say flip. Makes the inequality sign flip. So when you multiply or divide by a negative number, it makes your inequality sign flip. Okay, guys, let's go ahead and do a big star next to this. And if you guys did that exploration on your own, did you get this answer? If you did, very good work. Okay, especially with the confusing word operations there. It says here, we solve inequalities just like we solve equations, except, and this is the big except, this is one of the main goals of this entire unit, so make sure you're remembering it. Except when we multiply or divide by a negative, we switch the direction of the inequality. In other words, we flip the inequality. If it was a greater than, we make it a less than. If it was a less than or equal to, we make it a greater than or equal to. All right, so let's read this one more time because you've got to remember this. Not only do you have to remember it, that's only half the battle. The other half the battle, besides memorizing it, is actually remembering to use it when these cases arise. And we'll do a little practice here in a second. Okay, read it with me one more time. We solve inequalities just like we solve equations, except when we multiply or divide by a negative, we switch the direction of the inequality. Okay. So why would multiplying and dividing by negative change the direction? And it says, hint, what does negative mean? Well, at least in math, negative kind of means opposite, right? So if you're flipping a number to the opposite on both sides, it makes sense that the direction of the inequality would change because what was less than is now going to be greater than. Maybe kind of, sort of. Does that make sense? If not, you can always just memorize the rule, but I encourage you to play around with it until you kind of see the logic behind it. Let's do some examples. It says solve each inequality and graph the solution. Now this is going to be exactly like solving one-step equations with just that little extra rule about multiplying and dividing by a negative. Okay, let's do example A. 5x is less than or equal to 35. Let's get rid of the 5 because we need that x by itself, and we're going to get rid of it by dividing. So that's going to leave us with x less than or equal to 7. Okay, now let's put it on our number line. So I've got my 0 here. I'll put my 7 over here where the positive numbers live. I have a less than or equal to sign, so I'm going to draw a dot and fill it in because that or equal to part makes it into a closed dot. Okay, now I just need to figure out the direction of the arrow. X is less than or equal to 7, so all of the answers are less than or equal to 7. So we need the numbers that are less than or equal to 7. So we need the smaller numbers, and where do the smaller numbers live? They live to the left. All right. There we go. Let's do the next one. 30 is greater than or equal to negative 6r. Let me get this a little closer. Okay, there we go. So we need the r by itself, which means we need to divide by negative 6 to get rid of the negative 6. And hopefully some kind of alarm bell is going off in your mind because what did we just do? We just divided by a negative. Now here's what I like to do. The second I notice I'm multiplying or dividing by a negative, I'm going to circle the sign. You don't have to do this, but I find it's a really good way to keep myself from just forgetting. Like I know I need to flip the sign when I multiply or divide by a negative, but does that mean I always remember? Unfortunately not, so I like to circle it during this step just to remind myself. Okay, let's keep solving. 30 divided by negative 6 is going to give us negative 5, and now I'll bring down the sign except that circle tells me I need to flip it. So I'm going to write it like that. And now these go away and just leave us with r. So our final answer here is going to be negative 5 is less than or equal to r. Let's put that on the graph. So I have my negative 5 to the left of 0, where all the negative numbers belong, and I have less than or equal to, so let me fill in the dot because of that or equal to part. And it says negative 5 is less than r. Now remember, it's kind of easier if you read from the variable. I think it's easier. So the answers are greater than negative 5. The answers are bigger than negative 5. So where do the bigger numbers live? They live to the right, and we're going to draw our answer to the right. If you'd rather say negative 5 is smaller than the answers and think of it that way, you can, as long as that's working out for you logically and the arrows go in the right way. Okay, now that one's done. Let's go on to C. So here we have 2 is greater than y divided by negative 10. Now we got to get rid of that negative 10. Right now it's being divided by negative 10, so we're going to do the opposite. We're going to multiply by negative 10. So we're doing multiply by negative 10 on both sides. Oh, and now wait a second, alarm bells again. We're multiplying by a negative number here, so what do I need to do? We're going to have to flip that sign, so I'm just going to circle it. Okay. Now negative 10 times 2 is negative 20. When I'm bringing the sign down, I'm going to remember I have to flip it, so it's going to go that way. And these negative 10s cancel out, leaving me just with y. Okay, now I have negative 20 is less than y. Let's put it on a number line. Here's our 0. Here's our negative 20. And what kind of dot? There's no line underneath. There's no or equal to here, so I am not going to fill in my dot. It's going to be an open dot. Just like that. Okay, so negative 20 is less than y. That means y, or you could say all of the answers are bigger than negative 20. All of the answers are greater than negative 20. So we're going to draw a line out to the right because that's where the bigger numbers are. Numbers get bigger the further you go off to the right. Okay, and then we're done with that one. Let's go on to part D. Okay, y divided by 2 is greater than or equal to negative 10. Okay, so we have a division problem here. Let's get rid of the 2 in the denominator by multiplying by 2 on both sides. Sometimes I use the parentheses, sometimes I use the dot. Both work. These are going to cancel. You're left with y is greater than or equal to negative 10 times 2 is negative 20. So y is greater than or equal to negative 20. Did I need to flip the sign here? Nope, because all I did was multiply by a positive 2, just a regular old 2. So y is greater than or equal to negative 20. Let's put this on here. So here's a 0, here's a negative 20. Should I fill in my dot? Yes, I should. And now y is greater than, so the answers are greater than negative 20, so we should draw our line this way. Okay, going on to part E. It says negative 3 is less than x divided by negative 4. We're going to have to get rid of that negative 4. How are we going to do that? Right now it's dividing. We're going to do the opposite, which is multiply by negative 4. Now wait a second, we're multiplying by a negative number here, so we're going to have to remember something. That's our reminder. Okay, negative 4 times negative 3 is going to be a positive 12. Now I better flip my sign. And these numbers cancel, just leaving x. Okay, let's put it on the number line. We have 0 here. We're going to have positive 12 out that way. Is it going to be open or closed? It's going to be open because there's no or equal to. And now I'm going to read it from the variable, okay? So x is less than 12. The answers are less than 12. Okay, so the answers are going to be the lower numbers down this way. You could also think of it as 12 is bigger than all the answers. So if that makes sense to you, do it that way. All right, last example here. We've got F. It says 6z is less than or equal to negative 87. Okay, let's divide both sides by 6 to get rid of that number in front of the variable. We're just dividing by a positive, so do we need to flip the sign? Nope. We're going to be left with z less than or equal to, I don't know what. Let's use our calculator and find out. Negative 87 divided by 6 is going to be negative 14.5. Okay, so let's do our 0 here. And let's do negative 14 here and negative 15 here. And I'm just going to put my dot in between because negative 14.5 is halfway between negative 14 and negative 15. And it looks like I need to fill in the dot because of that line there. So there we go. And now let's read again. All the answers, the z, in other words, all the answers are less than negative 14.5. So we're going to draw towards the smaller numbers. Okay. And those were our examples. Let's go over a few little rules down here, little guidelines. It says, when solving inequalities, you must keep 3 things in mind. These are really good tips, especially number 1. Just because there is a negative in the problem does not automatically mean that you switch the direction of the inequality. It's only when you multiply or divide both sides by a negative that you switch the direction of the inequality, okay? It's only when you are doing it to the problem. It's the step you are taking that can switch the direction of the inequality. And it says to C, D, and F. So let's take a look. Okay, so C here in D, there's this negative 10 over here. But does that make the direction of the sign change? No, it doesn't. Not by just it being there. What did we do to the problem? That's the question we're asking. And what did we do? All we did was multiply by a 2, a regular positive 2. So in this case, the direction will not change. What about an F? There's a negative 87 over here. Is that going to make the sign change directions? No. And again, did we do anything to it involving a negative? Well, we divided by a 6, just a regular positive 6. So we didn't do anything involving a negative. That's why we keep the direction the same. Now, where did we have to change? Where we multiplied by a negative 4, where we divided by a negative 6, and where we multiplied by a negative 10. Those are the times where we did have to change the direction of the sign. Okay, so number 2. The solution to an inequality is all the numbers that make the inequality true. So it will be a whole range of numbers. Like for example over here, there's so many numbers that make this true. Negative 10, 0, 2, 5, 7, 1,000. All of those numbers make this inequality true. Okay, so it's a whole bunch of numbers. Number 3, it is usually best to read the inequality from the variable. And that's just what we were talking about, like right here where I said the answers are less than 12, instead of saying 12 is bigger than the answers. Both are fine. You just got to do what's right for you, whatever makes sense to your brain. Because none of us think exactly the same way. And that's all we got. So then you just have your assignment. You have a lot of in-between numbers. You don't have to be super exact on where you put these. If it's 2.1, just make sure it's somewhere between the 2 and the 3, okay? For fractiony looking ones, I suggest doing the top number divided by the bottom number so it turns into a decimal, and then it's easier to put on your number line. Here, when you're writing your inequalities, just guess. It's some number between 2 and 3. You might say 2.4, you might say 2.5. Maybe you get more creative, but make sure your number is about halfway between 2 and 3. What about this one? It's a number between 0 and negative 1. Looks like it's pretty close to the 0. So make sure it's a negative number, but yeah, somewhere between 0 and negative 1. Okay, and you've got 22 problems. If you have any questions, let me know. Thanks so much for watching, and have a great day. Bye.